is what we're going to do here now is we are going to turn this into a while loop. Okay, so rather than it saying for I equals 1 to 10, we're actually going to start off with while. We'll still need our end in there. I will say that this is going to look a little bit more complicated because we're going to need to define a few more things in the process here. And again, we're going to need to talk about our stopping criteria and our relative absolute error. Okay. And I just want to point out we're going to call our relative error here EA. Okay. And so we want this loop to keep running as long as this is greater than our stopping criteria, okay, which we'll call ES. Okay. So let me go ahead and again add in maybe some comments. So first term of Taylor series. Next, EA is the absolute relative error. ES is our stopping criteria. And let's maybe define what that's going to be. Let's just say that we want this absolute relative error to be less than 0.001. Okay. Now I'm going to suppress that. Okay. So again, this is going to run as long as this EA is greater than ES. Okay. And if you try to run this right now, you'll see that you run into an issue. Okay. And if we look down here, maybe it'll tell us what that issue is. Okay, it says unrecognized function or variable EA. Well, if I want this thing to start off and actually run, I need to define what EA is, and I would need it to actually be bigger than whatever ES is here at the moment. So maybe I could actually make it something that is smaller so you can see that this still won't run, but at least MATLAB won't get mad at us. Okay. Okay. And so you can see the while loop didn't run because it's only supposed to run as long as EA is greater than ES. And how do we know it didn't run? Because all that happened is we ended up with our approximation being 1, which is what we defined it to be for the first term up here. Okay, so next, let's make sure that this is actually bigger than ES there. So let's just maybe say 1. Okay. So now it will run now, but there's still another problem. If I try to run this now, it will never stop running. Okay. We would create an infinite loop here if we hit run, and you know we don't want that. Okay. We want it to actually eventually stop. So we need to, in here, write in our equation for EA. Okay, but before we can even do that, remember we would like to subtract our consecutive approximations, divide by the current approximation, and multiply by 100 to find EA. And so I haven't vectorized this like we did in our previous example. And I'm actually not going to. I'm going to take a different approach here. Okay? You can vectorize it, and I think that is at least for me, that's the easier way to think about it, is through vectorizing it. But another approach is we could maybe rename this. How about we call this old, and we'll call this E new, just noting that these are new and old approximations for E. Okay, and so now I can go in here and I can write that absolute value of E new minus E old, and then divide by E new. Okay. And actually, if we want to really ensure that we don't actually end up with any negative numbers here, it might not be a bad idea to put the E new in here. There we go. and the absolute value is what I was trying to get at, and then times 100. Okay, so there's that. But we still actually have a problem. If we were to try and run this now, after one iteration of this loop, E old is going to stay the same. It's going to continue to be 1, but we want it to update. So as what we'd want to do here is we would want to say that after computing the error, this E new that we just found is now going to be the E old for our next iteration. Okay. Right, we're going to need a new E old as we do the next iteration of this loop. Okay, and then there's one more thing that needs to change. So with the for loop, it was essentially built in that I was changing, right? Here that's not the case. So what we need to do is we need to note what our first value for I is. Oop. So right when we were doing our for loop, the first value for I was I equals 1. And then is what we want to happen is as we run this, we would like I to update. And so we could say I is equal to I plus 1. Okay, so every time this runs, I increases by 1, just like it did in the for loop. Okay. I'll put another comment in here. Okay. And so for now, we could just go ahead and run this and see what happens, but I'll add maybe an extra output or two here. Let's just hit run, see if we run into any issues. Okay. So we did, and you can see it says error, and then it notes that there's an unrecognized function or variable exp. Well, that's because I'm not using exp here anymore, right? We want to use E new. That's our new approximation for E. And there we go. There's our approximation. It looks pretty good. Okay. But if you are making this approximation, you might want a little more detail. Like maybe you want to know, well, how many iterations of this were there? And so you could say I, right? How many times did this while loop run? And you also might be wondering, well, what did that absolute relative error come out to be? And so we could make it output, you know, again, our number of iterations and our absolute relative error. And if we wanted to, we could even say this, absolute relative error is equal to, and then here we could say number of iterations, and we could call this our approximation for E. Maybe I'll put it capital so it's a little more clear, but then we can go ahead and hit run here, and if we move up so we can see our command window where the output is, there we go, you can see here's our approximation for E, the number of times this while loop ran, and the absolute relative error here, okay, which is pretty small. Okay, so we did make it past that stopping criteria, which is what we wanted. Now we can make this even more useful by turning this into a function, and we'll go ahead and we'll do that in our next video. And part of the purpose for turning this one into a function is it's a little more complicated than the function that we made yesterday, and it will also have multiple inputs, multiple outputs, as opposed to the function that we created last time where we just had one input, one output.